Hey, welcome back to the Network Plus training series. This lesson we're going to cover Objective 1.2, making sure that we compare and contrast networking appliances, applications, and functions. Now, by the end of the video, I would like you to be able to identify and describe common physical and virtual network appliances, making sure that you understand the roles of networking applications and explain core network functions like VPNs, QoS, and what time to leave means. We're going to start with physical and virtual appliances. In modern networking, many can exist as dedicated hardware appliances or virtualized instances running on a hypervisor. It is key to understand both of those forms because it's critical for the exam and, of course, real-world deployments. The first appliance we will discuss today is the router. And a router is a layer 3 device that connects different networks together and make forwarding decisions based on IP addresses. Routers are going to help us maintain routing tables that contain information about network destinations and the best path to reach them. They can use static routes or dynamic routing protocols like OSPF, EIGRP, or BGP, just to make sure they can learn those routes automatically. The routers also perform network address translation or NAT and often include basic firewall functionality. The next one is going to be the switch, and a switch is a layer 2 device that connects devices within the same network and forward frames based on MAC addresses. These devices can also be layer 3, but we're going to focus on the layer 2 aspect of the switches. These guys maintain a MAC address table, which is also known as a CAM table, and this one maps the MAC addresses to specific switch ports. Unlike older hubs that broadcast traffic to all ports, switches intelligently forward traffic only to the port where the destination device is connected. This dramatically improves network performance and reduces unnecessary traffic. And as I was saying, there are also layer 3 switches, sometimes called multi-layer switches, which can perform routing functions in addition to the switching. Next, we're going to talk about the firewall. And the firewall is a security device that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Firewalls can be hardware-based or software-based or a combination of both. They can operate at multiple OSI layers, and in this case, packet filtering firewalls work at layer 3 and layer 4, examining source and destination IP addresses along with port numbers. Stateful firewalls track the state of the active connections and make decisions based on the context of the traffic. Now, the next generation firewall incorporate additional features like deep packet inspection, intrusion prevention, and application awareness, amongst other things that it can do. An intrusion detection system, or IDS, monitors network traffic for suspicious activity and alerts administrators when potential threats are detected. An IDS is passive, meaning it observes and reports, but it doesn't block the traffic. Now, in contrast, we have the intrusion prevention system, which is an IPS, and this one goes a little step further. It sits in line with the network traffic and it can actively block or prevent detected threats in real time. Many modern appliances combine IDS and the IPS functionality. A load balancer distributes incoming network traffic across multiple servers to ensure no single server becomes overwhelmed. This improves application availability and performance. Load balancers can operate at layer 4, distributing traffic based on IP addresses and port numbers, or in some cases at layer 7, making decisions based on application level data like HTTP headers or cookies. Common load balancing algorithms include round robin, least connections, and weighted distributions. Proxy server acts as an intermediary between clients and servers. When a client sends a request, the proxy forwards it to the destination server on behalf of the client. Proxy servers can provide caching to improve performance, content filtering to enforce usage policy, and anonymity to hide the client's IP address. Forward proxy acts on behalf of the internal client accessing external resources, while a reverse proxy sits in front of the servers and handles incoming requests from external clients. Network Attached Storage, or NAS, is a dedicated file storage device connected directly to the network that allows multiple users and devices to access the shared storage. NAS devices use protocols like NFS, SMB, and CIFS to provide file-level access over the network. They're relatively easy to deploy and manage. In contrast, we also have a storage area network, or a SAN, which is a high-speed network dedicated to providing block-level storage access. Unlike the NAS, which provides file-level access, a SAN provides raw storage blocks that the server's operating system treat as locally attached storage. SANs typically use fiber channel, high-SCSI protocols, and are common in enterprise environments requiring high-performance storage. Moving into wireless devices. Wireless devices is some of them are going to be access points or wireless access points. It's a device that allows wireless devices to connect to a wired network. Access points broadcast SSIDs and handle wireless authentication and encryption. A wireless controller is a centralized device that manages multiple access points. And in this case, controllers handle the configuration, firmware updates, security policies, and roaming between access points. This centralized approach simplifies management in environments with many access points. Moving on to the network applications, we're going to talk about the Content Delivery Network, or CDNs, as you may see them everywhere. It's a distributed network of servers that delivers web content to users based on their geographic location. CDNs cache content at the edge locations around the world, reducing latency and improving load times for end user. Popular CDN providers include Cloudflare, Akamai, and Amazon CloudFront. Covering a little bit on the network functions, we're going to talk about a VPN, or a virtual private network. And in this case, this function creates and secure encrypted tunnel over a public network like the internet. VPNs allow remote users to securely access internal network resources as if they were connected directly on that local network. Common VPN protocols include IPsec, SSL TLS-based VPN, and WireGuard. Quality of service, or QoS, is a set of technologies and techniques used to manage network traffic and prioritize certain types of traffic over others. QoS is essential for ensuring that time-sensitive applications like voice and video receive the bandwidth and the low latency they require. QoS mechanisms include traffic classification, marking, queuing, and policing. Time to leave, or TTL, is a value in an IP packet header that limits the lifespan of a packet on the network. Each time a packet passes through a router, the TTL value is decremented by 1. When the TTL reaches 0, the packet is discarded. This prevents packets from circulating indefinitely on the network in the event of a routing loop. TTL values are also used in traceroute operations to map the path of packets take through a network. As a quick summary, we're going to talk a little bit about what we covered. And in this case, we discussed physical and virtual appliances, including routers, switches, firewalls, IDS, IPS, load balancers, proxies, NAS, SAN, and wireless devices. We also cover other application functions like a CDN as a network application, and then we explain key networking functions like VPN, QoS, and TTL. For the exam, make sure that you compare these devices and functions, making sure that you understand not only what they do, but how they are different from one another, and in what scenarios we use each of them. Thank you for watching, and in the next lesson, we will cover Objective 1.3 on cloud concepts and connectivity options.